In this video, I'm going to step you through how exactly you would accomplish the tasks related to ggplot in week 7. I've already got the RStudio API code set up for the first few lines of our project. So that's obviously lines 1 through 3. Line 5 is going to tell me to write a comment that says libraries, so I'll go ahead and do that. Of course, at this point, we don't really know which libraries we need, so we might as well just skip down a little bit. On line 10, we're going to write a line that says data import and cleaning. And line 11 through 17, we have a number of tasks to accomplish. So using a single pipe, so that means we need something tidyverse. Import the data set as a tibble, call week 7 tibble, converting any data types not imported correctly, which is an interesting piece. Using tidy functions where possible, that's important too. And relabel factors according to table 1. So that's a lot of things to do in a few lines. Line 16, remove all cases that failed the manipulation check. And line 17, drop Q6 from the final tibble. So this really sort of replicates your normal workflow that you would have in a situation where you had a manipulation check written into your survey items, and you just wanted to just totally drop all those cases so they just basically didn't exist for any of the analyses you were going to do. Normally you wouldn't do that in a real kind of data analysis scenario because you would want to do some diagnostics on those cases. You'd want to figure out, are the cases that failed the manipulation check systematically different in any way from the ones that didn't. But for this assignment, it's pretty straightforward. So line 11, using a single pipe, import the week 3 data set. So if we want to use tidy functions, that means we're going to need to start with library tidyverse. We could use reader here if we really wanted to. Wouldn't really make a difference yet. As a tibble, call week 7 tibble. So that's easy. Week 7 tibble gets. That's going to come from an import of the week 3 CSV dataset, and I've already put that where it's supposed to be. So I'm going to do read underscore CSV, and that's down in the data directory, and it is called all lowercase week 3. So we'll put that in, week3.csv. And let's just see what that looks like to begin with. We got to actually run our code here. And even after I said all that, I didn't actually type it. Whoops. So here's our beginning tibble. Now, we definitely are going to want to open up this CSV first just to make sure that it's the first few lines are coming over the way that we think they should be coming over. The several different ways to do that. I'm going to do show folder in new window and open up the CSV in Excel just because it'll be a nice convenient way to do it. You can see nothing weird happened with the file conversion. Excel can see it pretty easily, so that's a good sign that read underscore CSV was right. We might also want to throw it into a plain text document just to make sure. So if I head over to that, and I'm not showing you my file system right now, but rest assured that's what I'm doing, navigating through file structures. Projects, week 7, data, and all files, week 3. If we look at that raw file, you can see that it looks pretty good. There do seem to be no quotation marks around these date columns, but they are pretty clearly delimited by commas, so probably no problem there. If we double check that against both Excel and against R, it looks like it came through okay. We'll use that view command to pop it up here. Yeah, looks just totally fine. So we are safe in this case. Always good to do your due diligence. We are safe, however, to use just an ordinary vanilla read underscore CSV. Let's pipe that into the next command, see what we need to do next. Line 12 through 15. So convert data types that weren't imported correctly into correct types and relabel factors according to table 1. Okay. So we're going to use mutate for that. If you used reader, you would have to, at this point, also import the dplyr library because mutate's not part of reader, but tidyverse just does everything for you. And we're going to need to start converting stuff. So what came over incorrectly? Well, the first thing you can see right here is time start came over as characters. You could try to manipulate this using as.posixct, but you might end up with some weird results later if you do that. Unless you specify these dates. The reason for that is that in this format, we actually have non-compliant POSIX times in this time start column. That's why it didn't auto-convert, and you should always track back why conversions don't happen. In this case, it's because we're actually missing leading digits on some of our hours, so this is not actually a POSIX date. It's very similar, but it's not quite it. So that means that we would be much safer off using the lubridate package, so I will go ahead and add that as well. And I'm going to mutate, and I'm going to do time start gets a year, month, day, hour, minute, second version of time start. So great. And I'm actually going to just go ahead and roll forward each command. So on line 12, we have our first type conversion, and we might need to reorganize this later, but we'll just keep moving for now. Condition and gender are not correct. And we were also asked to relabel those factors according to table 1. These should be factors, but you can see they came over as character vectors. If I look down here, I can see condition, level A, B, and C, label block A, block B, and control, and gender, M, and F. So the easiest way to do this is to use condition equals factor of condition with levels equals C, A, B, C, and we're going to use labels of block A, block B, and control. And let's see if that runs. It might or might not. Yep. We got our factor. It came over as block A, B, B, A control, B control, B. At this point, I like to just go back and make sure that looks like what I thought it did. So let me go back and check. So B, A, C, B, C is the pattern. So if we go back, run one more time, B, A, C, B, C. So it did convert over correctly. That's going to be more important for your second factor variable, which is gender. And the reason for that is, and it's been a few weeks since we talked about this, but the reason for that is that remember that by default, levels are defined alphabetically. So you would have to just remember that you wanted to define your labels alphabetically if you didn't also specify the levels in the order that you wanted. So for example, I can do levels equals C, M, and F, and then I can put labels equals combine male, female. That would work. It should work at least. Where we are specifying, oh, I put condition. There we go. And I caught that, by the way. I'm going to rerun that just in case you didn't see what I just did. I did male, comma, female. And I did a check that you didn't even see. I looked up here very briefly and noticed that I have all NAs. So that means something went wrong. And so if I go back here, I can make sure that I did that correctly and re-specify that as gender. So that ended up with a 2, 1, 1, 1, etc. If I go back to the tibble, I have female, male, 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 female. If I go back here, I should end up with the same pattern, just to double check. Yep, F, 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 M, 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 etc. And the reason why that's important to do it that particular way is because if, for example, you just did labels as the command, you use the labels command, and actually just specified labels, gender, well, week 7, tibble, gender. If you did it that way, then it's going to do it alphabetically. So that means you would have to specify female first. It would also work in this statement as well. If you left out levels entirely, I'll show you, and I ran it, that's going to end up flipping the order. But if I just reordered them this way, then it would come out correctly. So you can see everything flipped around correctly. So that means it's always safest just to use this full-blown factor command, just so you know that the specific levels coming in and the labels that they're given are, in fact, what you meant to do. So yeah, that looks like, is that everything for our first requirement? Convert any dates not imported correctly into correct types where possible and relabel factors according to table 1. So yeah, I think we're ready. We have 2 dates, 2 POSIXs, we have 2 factors, and then we have a bunch of integer vectors. So that looks correct. So we're ready to move on to our next command. Online, that was 12 through 15. Yeah, and then on line 16, we're going to need to remove any. Yeah, this is right. I need to remove any cases that fail the manipulation check, which is a response of anything other than a Q6. So actually, we're going to do that inside this. No, we're going to do that outside the mutate also. We're going to use this as a filter command. And we're going to filter by where Q6 equals 1. And that should mean that all of our Q6s are now 1. Yes. Our observations also dropped. Yes. Very important to do those spot checks. Next line, and that's 16. That's okay. And then line 17, drop Q6 from the final tibble. So if I do that, I will do select minus Q6. You could also do select and then select everything in. It's just a lot more code to do it that way. Yep, then we should be good. So that ended up taking through line 17. We're going to skip line 18. Just making sure everything looks okay here. 12. Yes, okay. And line 19, write a comment that says visualization. And we're ready to start doing some of our ggplot work. So for line 20, create a single figure displaying a scatter plot and correlation matrix of Q1 to Q5 and Q7 to Q10, as well as density plots, which is the line graph version of a histogram. Do not use ggplot. So you could use ggplot to create what I've described, but the problem is that it would require a huge number of ggplots or some really very clever coding. In our last lecture material, I introduced this other package called ggalley. And if you run the ggalley package and we head back down to line 20, we can use the ggpairs command in order to view this whole tibble. Now, a catch of this is that I said specifically only display a scatter plot of Q1 through Q5 and Q7 through Q10. So you would probably need to specify which pieces of that you wanted to use, or you would need to do that. The easiest way is just to specify it by columns if you wanted to keep it all on one line. So we want all rows, but we only want variables 1, 2, 3, 4, 5 through 6, 7, 8, 9, 10, 11, 12, 13, 14. And if we run that, we should, 13, got it wrong. We get 5 through 13. It's going to create all of our plots for us, one by one. And then in the plot section, we're going to see this appear. There it is, Q1 through Q10. And because we already selected out Q6, that works just fine. Alternatively, you could have done this using Magritte notation if you wanted to within a pipe by doing something like week 6 tibble into select starts with Q and then pipe that into, very wrong pipe that into ggpairs with no settings, and that would give you the same plot. So this should always be that first step of your data analysis, and you can see already from this one that we have some weird looking data. We have some bimodal distributions down here. We've got some normal, somewhat normal distributions. We have a flat distribution, uniform distributions, just all sorts of weirdness going on. So if this was a real data set, it doesn't look too great. What you are seeing, the reason that's happening is because I generated these at random from uniform distributions. So every number had basically an equal chance of appearing, and the sample size is relatively small. So you end up with kind of a weird distribution of these as a result of that. Fine for our testing purposes, but if you saw real data like this, you might be a little worried. Line 21, we're going to keep moving down. Line 21 through 24, check for differences in Q1 over time by creating a plot of time start on the x-axis and Q1 on the y-axis that looks like Fig 1. So here's Fig 1. That's your very basic kind of scatter plot. So let's just go ahead and start the bare bones of it. We have our ggplot specification of week 7 tibble, going to set our basic aesthetics to x equals time start and y equals Q1, because that's what we were asked to do, I believe. Yes. That's going to give us a basic sort of setup. You can see that we have some real nice looking months on the x-axis by default, and we have numbers on the y-axis by default, and that's what's in our target figure, so great so far. But we're missing a few other things. We're missing these labels, and we're obviously missing the scatter plot itself. For that, we're going to need to start to add in a geom point. That's going to create our actual scatter plot, and that looks identical. So those two scatter plots are exactly the same, so that means we're on the right track. But now we need to do some of the touch-ups here, right? So things that are not quite right now. One is that this time start should be called date of experiment. So we're going to need to add a scale something, scale x, and then we're going to need to add a character here, or a type specification. If you're not paying attention, then you might have just used the two that were specified in data camp over and over again, which were time scale underscore x underscore discrete or continuous. But this is a date time. So we already know that because when we look over in our environment, we can see it's specified as POSIX-CT. We even explicitly use LubriDate to do that. So that means we need to specify the same thing here, scale x date time. We're going to call it date of experiment. And that's all we need to do, probably. Let's just check it to make sure that it runs. Yep, we got date of experiment on the bottom, which matches our target. I bet you can guess then what the other is. This is a continuous scale, even though it doesn't look like one, because Q1 score is not being treated as a factor. It's being treated as a continuous variable. So I'm going to call this Q1 score, and now they look exactly the same. So we're done. If we had done discrete here, you might ask what would have happened. The answer is that we lose the axis because we have no labels for what 1 through 5 mean. So you would have to specify that as a factor and then give names to 1, 2, 3, 4, and 5. That would enable scale y discrete to work. But as is, we just use this one right here. All right, line 25, check for gender differences in the Q1, Q2 relationship. So there's a lot of pieces there by creating a figure that looks like 2. And notice this is a jitter plot. So this is pretty straightforward. We don't have any weird looking axes in this case. We're just going to go ahead and start with our basic jitter plot. Week 7 Tibble. Define aesthetics with x of Q1 and y of Q2. And it looks like different colors for gender. So we do color equals gender. And we already said it was a jitter plot, so that was easy. We just do geom jitter. And that's it. We're done. The jitters, you notice, will appear in different places because it's actually jittering on both dimensions. So you're seeing x and y shifting around. But the same general pattern is there. So like in this graph, for example, you can see these two red dots, the male dots, were up here in this graph. We wouldn't normally use a jitter plot for relatively little data, or we would use a smaller width jitter plot. But if you notice, if I use geom point, for example, I just end up with this not real super informative thing. So instead of a jitter plot, I might have done transparencies so that the dots are brighter or multicolored as they overlap. But jitter is enough here. But otherwise, that's it. We meet all the requirements, and we look at pretty much just like that figure by doing it with just these two specifications. So we're done. That's it for line 25. All right. Next up is line 27 through 31. Check for gender differences in Q1, Q2 again, but this time by creating two side-by-side plots. Ooh. So we're changing things up a little bit, and the key thing I was trying to make you remember here is that you really shouldn't just blindly copy-paste if you're trying to recreate a plot, because now color is no longer specified at all in the base plot aesthetics. Instead, what we're doing is we're actually creating separate plots entirely that are based, and that's going to obviously be based on facet grid. So let's go ahead and start that. We're going to still use geom jitter. Then we're going to do facet grid. We're going to use formula notation in order to get gender in separate plots. And the project asked for side-by-side, so this was right. So we have two columns. That's that second part of the formula. Two columns based on gender. But if we look down at the plot, there are a few things different still. We have these two labels for score on Q2 and score on Q1, so we're going to have to fix both of those. Scale X, and this time they're going to both be continuous again, and that's score on Q1, right? Yep. And then scale Y continuous, score on Q2. And recreate. Male, female, we got a jitter, points are more or less the same place, score Q2, score Q1, yes. So everything is roughly in the same place, and we have all the correct axes. So we're done. That's figure 3. For figure 4, let's see what this says. Using a single pipe, so this is making this a little weirder. Create a plot displaying the experimental time elapsed in seconds between time start and time end split by gender, looking like figure 4. Ooh. So for figure 4, now we still have gender on the bottom, but we have time elapsed on the y-axis. That means that we need to create a new variable in our tibble on which to create the ggplot. So that's why that pipe requirement is there. That means we need to take week 7 underscore tibble, and we need to modify it in order to create the thing that we need to create. So I'm going to do mutate. Let's create a variable called time diff, I guess, for time difference. And then we're going to use our classic function from several weeks ago, diff time. Diff time between, where is it? Time end and time start. I think that'll be positive. Let's just check to see what that looks like before we go too far. And we can't see it yet. So let's add a view command just to take a look in this format. So we have time diffs. Ooh, those are not seconds, because if we look over here, we have 11, 11, and 11, 18, and that's a difference of 7 minutes, not seconds. So we need to use that other diff time element. If you forgot what it is, you might go ahead and check, question mark diff time. Oh, right, it's called units, and it's going to take a string called sex. So we're going to do units equals c sex. Let's review that, make sure that looks right. Yep, 439 seconds. It sounds a little bit better. So now we have the information we want in the data frame. So now we can feed this into ggplot. And we can take, because we're feeding it in, that means that it serves as the first variable automatically. So this is the same as doing ggplot, open paren, and then all the stuff I just said. So the result of that table mutate command. So if I do ggplot, and that means I can jump straight into the aesthetic. X is going to be gender, and Y is going to be our new time diff variable. And then I'm going to go ahead and create a geom box plot instead of the other piece we had. And, oh, I still got a view command, so that's not at all right. So let's kill the view command. We have, don't know how to automatically pick scale for object of type diff time defaulting to continuous. Well, so we're going to have to fix that. But we got the first part. These two, this box plot looks right as a basis of what we're trying to get to. We need to change this, and we need to change this, and otherwise it looks okay. So we can do time, we can do scale x discrete because we're talking about gender, and we're going to label it with gender capitalized. And then we're going to take scale y what, and this time it's a time difference, so that's continuous. It's just a numeric value, and we're going to call it time elapsed in seconds, as the graph we are looking at does. We see the warning disappears because now we're telling it how to course that value, and you can see we have time elapsed 500, etc. So if we wanted to get this to go all the way down to 0, we would want to add in a theme layer at this point. With a y-lim on it. So for example, I could do a chord Cartesian. A chord Cartesian with a y-lim of 0 to 1250. Looks like kind of where it is. Yep, and see now we have the graph all the way down to 0. So this would be more appropriate for a publication. So, yeah. So if we get rid of that, because we don't need it for this one, and we do week, where we go? We go to Fig 5. That's going to be a little bit harder, because it's the last question. Recreate Fig 5. Jitter may be slightly different, but should be similar. The background of the legend is 12.5% gray. Ooh. Hint, tackle this figure 1+ at a time, checking your work as you go. Okay. So we don't have a lot of instructions for this, but we know that we're creating a ggplot, and we're doing it on the basis of experimental condition and Q7 score, so that means we don't need to make any new variables or anything. We can go ahead and start it with week 7 tibble and aesthetics with an x value of what is it? Q5. Whoops, sorry. We have Q5 on the x-axis. We have Q7 on the y-axis, and then we have different colors to indicate the different experimental conditions. So by default, let's see what that looks like, and we'll use geom jitter again. Okay, so that's roughly where we're going. The legend's in the wrong place, the labels aren't right, and there's no lines in it, so there's some things to do. I'm going to put geom jitter on its own line just for clarity. So the first thing we need to do is figure out how to get those lines on there, right? So if I am trying to get lines, I am probably going to use geom smooth. Let's see what that does. Ooh, lots of warnings. And I'm ending up getting all like error bars, and those are lowest smooths rather than linear regressions, which is what's clearly in that figure. So I'm going to change my smooth. I'm going to use SE equals F to get rid of the lines. I'm getting still a lot of different errors because of the low S, or the lowest. And if I... yeah, and I want to change those into linear regressions, so I'm going to convert that into method equals LM, which stands for linear model. Oh, now no errors, and now we have lines, and those lines look just like what we started with. So we're one step of the way toward getting this completed figure. Now let's go ahead and change the two axes. So we have scale X continuous. That should be called score on Q5. Then we have scale Y continuous also, which should be score on Q7. Let's see what that looks like. Make sure we're going right. Yep, everything is still functioning as intended. That legend is a little concerning. As long as we're doing scaling, we can rescale the legend too. And you might not have remembered how to do this, but because we specified up here that condition is color, that means we're changing scale color also. However, not continuous, it's discrete. So we want to change the label of condition to experimental condition. All right. So next problem is all positioning. I mean, we have all the components. The scaling looks right. Well, actually, one thing doesn't look right, which is the jitter. And I mentioned that in the question too, didn't I? Jitter may be slightly different, but should be similar. So the jitter we have right now actually looks way off from the jitter that is presented in figure 5. These are all very tightly organized around each of these points. So that means we need to re-specify our jitter. And we can do that in the width command. Width equals, I don't know, let's try 0.1, see what that looks like. Pretty good. This graph looks a little smaller. As long as you're somewhere in the ballpark of this number, that's fine, but the number I actually use is 0.05. So that will get us to even closer to what this figure should end up looking like. If I hit plus, I can add the next piece. So in order to make this look like this, there's a lot of different aesthetic things that have changed. So we had all the default ggplot backgrounds in all of these previous figures, but now the background's gone. And the axes look a little different. Like, we're gonna have to try to figure out what exactly has changed in order to get to this point. Now you might, this is all done in the theme command, so I'll go ahead and open one of those theme commands. You might at this point have gone with one of the default plots, because there's like default black and white plots, and you might have started with a default like empty plot and then added colors. I'm gonna go the other way, and I'm gonna just kind of modify this piece at a time to get to where I want. First obvious thing is that this panel has a background and this panel does not. So why don't we get rid of the panel background. Panel background equals element blank. We run that. All right, we're closer. There's no backgrounds on this either. But the legend's in the wrong place, so that's throwing the whole thing off a little bit. I'm going to go back to the theme, and I'm going to say legend.position equals, and at this point you would use one of the presets, which is bottom. And again, if you forgot what those presets were, you can always do $theme and scroll down. So you'd be like, oh, I need a position of a legend. What does that look like? And you would have been like, oh, legend position, and here's all the possibilities for where it could go. So if you go to bottom, you will see that we end up with it just where it is in the assignment. So this is the same thing, but the difference is there's this big gray background to that legend. So we're going to have to fix that next. If I add in a command legend.background, I now need to get to the color that I'm specifically looking for. And in this case, I was told that this is a 12.5% gray. So the easiest way to figure that out is to go into your programming calculator in Windows that I showed you last time, move from standard to programmer. And then out of 255, instead of 255, I'm going to want 12.5% of that. Actually, let's go back to standard and do 255 times 0.125. And that equals about a 32. So that's fine. If I go into decimal and enter a 32, you can see that is hex 20. Now, that's intuitively what you might do. But what happens if I actually give it a color? So legend.background, if we go back to our help file, is an element rect, so that's what we're going to need to give it. So if I give it element rect, and then I give it a background color of, what should it be, 2020. Is that going to be 12.5% gray? No, that's not 12.5%. That is not, whoops, that's not anything. There we go. That is not 12.5% gray, that's 85% gray, or 88.5% gray. 87.5% gray. So we actually went in backwards direction. This is 87.5% gray. So we actually don't need 0.125 times 25. We need the opposite of that, 0.875 times 255. We end up with 223. So if we do back in our calculator, decimal of I already forgot it. Whoops. 0.8875. Skipping steps. 0.875 times 255 is equal to 223-ish. And if I take 223 here, I end up with a DF. So let's try that. Let's see what DF looks like. DF. And now we're actually doing pretty close. That's pretty close to the gray that is in that original figure. And you can check back to see, oh yeah, they look roughly the same. So yeah, is there anything else left to do to get this figure the way we want it? Doesn't look like it. Everything seems to be taken care of. So at this point, we're done. And you would have a completed ggplot based on the entire assignment. So that's basically it. And I hope that what you noticed as I went through that was a constant, just like in every other week, a constant do it a piece at a time, check how the individual pieces are progressing. Don't ever just skip over something and assume it worked. Don't ever just arbitrarily write code and without checking it. Instead, if you're not quite sure what the calls are, go back to the help files, which, I mean, it is literally a reference guide. It's like having a dictionary sitting next to you. Use your dictionary. Don't just assume that you remember things. But those kind of things are the sort of best practices that are going to lead you to be able to create whatever figure you want in a very short amount of time. And that's going to become increasingly important as we start to move toward creating real diagnostic plots and publication-worthy plots based on real data, as we will be doing for next week. But yeah, otherwise that's it for our ggplot content.